This is the second video of the ECG series. I'm going to focus on how do you get a 12-lead ECG reading from just having 9 leads attached to the patient, and how do we remember the angle of the axis. They are all facts that can be reasoned out instead of blindly memorized. Let's start with the limb leads. A cool fact about them is that they are the only ECG leads that are bipolar, meaning they can function as both a positive and negative pole. I'll explain more later. In a practical setting, they are color-coded as red on the right hand, yellow on the left hand, green on the left leg, and black on the right leg. And we attach this lead on the right leg because it has no real influences on the ECG, and you can think of it as a reference point. From these limb leads alone, we are able to generate lead 1, 2, and 3 on the ECG strip. Lead 1 senses current from the right upper limb to the left upper limb lead horizontally, and lead 2 senses the current from the right upper limb lead to the left lower limb lead. Lead 3 senses current from the left upper limb lead to the left lower limb lead. And let me replicate it on the other side. As you can see, it forms a triangle, and I draw them as arrows because the direction actually matters a lot, and it allows you to reason out why some leads on the ECG strip are predominantly upward or downward pointing. Also, when I forget which direction is lead 3, for example, I'll just need to remember lead 1 as horizontal and lead 2 as the axis that is closest to the heart. And then lead 3 will be whatever is remaining to complete this equilateral triangle. And because it's an equilateral triangle, the total angle of the triangle is 180 degrees, and each edge is 60 degrees. And from this, I can reason out that lead 1 is always the baseline, which is 0 degrees. Lead 2 will be at 60 degrees. And lead 3 will be 120 degrees. As you already know, there are 6 chest leads, namely V1 to V6. And these are different from limb leads because they are unipolar leads, which means they measure the current directly from the heart. And this is why they are more prone to human error because their exact attachment location is more strict compared to the limb leads. Also, this is why V1 and V2 are known as septal chest leads because they tell you more on the location of the septum of the heart. V3 and V4 are the anterior chest leads, and V5 and V6 are the lateral chest leads. They correspond to different sides of the heart depending on their location in relation to the heart. Now that we have 6 chest leads and 3 limb leads, which gives us 9, the remaining 3 are known as augmented leads, and they are AVL, AVR, and AVF. They are basically calculated leads, which means the leads are not put on the body like the rest. Like the chest leads, there are unipolar sensors that measure the flow of electricity from the heart to the limb leads. If you want to figure out the exact angle of these augmented leads, you can figure out by thinking about them as tangents to lead 1, 2, and 3. A tangent from lead 1 gives you AVF, and it is 90 degrees from the baseline. A tangent from lead 3 will give you AVR, which is an angle of minus 150 degrees. And lastly, a tangent from lead 2 will be AVL, which is minus 30 degrees from the baseline. Therefore, by remembering this triangle formed by the limb leads, we can also reason out the angle and direction of the augmented leads. Personally, I remember them as AVL because the L stands for left, which is left arm. Therefore, it points towards the left arm. AVR is R, so it's right. Therefore, it points towards the right hand. And then AVF, which is the only one left, will be pointing directly downwards. And this concludes this video.